Here we go with another video here, this one explaining how to do mass-to-mass stoichiometry problems. How do we take the mass of one substance and change it to find out the mass of another substance in our chemical reaction? Let's take a look at what we're doing. For mass-to-mass calculations, this kind of summarizes what we're going to be doing. We're going to take the grams of one substance, we're going to change it to moles. We'll take the moles of that substance and change it to moles of another substance, and then we'll take that and we'll change it to grams. Where are we looking at in terms of our flow chart? Well, this is the area that we're going to be focusing on for this flow chart here. We're going to start with the mass of one substance and change it to a mass of another substance. We're going to start out with mass of one substance, change it to, the moles first. And it says right here, in order to do that, like we've been doing, we're 1 mole, we're going to look at the molar mass, and we get that from the periodic table. So we'll remember that. We'll kind of refresh our memories on that. The last video you guys learned how to do the moles of one substance to the moles of another, and it says that we're going to focus on the balanced equation to do that. Then we're going to take our moles of our new substance and change it back out to mass using, again, the periodic table. How are we doing this? We're going to take the moles equal to the molar mass from the periodic table. So long and short, we're going to be doing these 4 steps here, taking mass, going to moles, taking the moles of one substance, going to the moles of another substance here, and then taking that and going to the mass of our substance that we're looking to get to. Now, when we're looking at this flowchart, I want you to kind of realize that we're starting here on the left side. So we're going to start here on the left side of this. This is what our given quantity is. So this is where we're going to start. We are starting here with mass. We are going to go then to the right side here. This is where we're going to end. Oops. So we'll end here on the right. So end on the right. This is what we want to solve for. So this is what we're looking to solve for. So that's what we're going to want to figure out. Let's take a look at a practice problem and see how these work. Alright, our first step, as always, it says, is to balance the equation. So that's going to be our first step in this example. I got to balance this equation that I have. It says calculate the number of grams. So I'm looking for the number of grams of this aluminum chloride that I can produce by reacting 5.4 grams of aluminum with an excess of chlorine. The excess of chlorine means that I'm going to have plenty of chlorine. First step, we've got to figure out this equation. So it says aluminum chloride, and that is what is being produced. So that's going to be my right side of my equation. So I have aluminum and chloride. It's an IDE ending, so that means it's a compound. That must mean we've got to look up the charges from the periodic table and crisscross them. If we look at the periodic table, aluminum is in group 13, so this is going to have a charge of a +3. Chlorine's in group 17, it's going to have a charge of a -1. And we got to crisscross this to get our compound, our formula here for aluminum chloride, and I get AlCl3. That's actually my product side of the equation. That's going to be the right side of the equation. What I'm starting with, the reaction, is between both aluminum and chlorine. So aluminum itself is not in a compound. Anytime I have an element by a compound, I just write the symbol of it, just like that. Chlorine is not in a compound. There's nothing else bonded to it. It does not end in IDE ending, so I just write the symbol of it there. But anytime we write symbols, guys, remember we have to look and double check for our rule of 7. Remember what our rule of 7 was? We go to the 7th element on the periodic table. We'll make a 7 like so. And then we'll also include hydrogen in this. And all of those in my rule of 7, these were the diatomics again. Diatomic meaning that we're going to have 2 atoms. Right? Notice that chlorine here, the one that we're using, chlorine is actually in that rule of 7. So when I have chlorine by itself, I'm actually going to have 2 of them. That's what we're trying to show you there. That chlorine is never by itself. It's always bonded to itself. We'll have 2 chlorines in this. This is the equation that I'm starting out with. I've got to balance this equation. I'm going to go through this quickly because we should know how to balance. I've got 1 aluminum here. I got 1 aluminum here. I got 2 chlorines here. I got 3 chlorines here. 2 and 3, I want to make 6. So let's make 6 on this side. To do that, I'm going to put a 2 in right there. That gives me 6 chlorines. To do a 6 on this side for the chlorine, I'll put a 3 in right there. That gives me 6 chlorines. This 2 also gave me 2 aluminum, so I need to put a 2 in front of my aluminum in this equation as well, and that's my balanced equation. Let's make this look a little neater by using this equation. Same thing instead. So first step was to balance the equation. We've got our balanced equation right there to start out with. Now, our next step is the grams to grams conversion. Again, if we're looking at our flow chart on this, I am starting out in right here in mass. So I'm starting out with grams of a substance. I'm starting out with 5.4 grams of aluminum. So on this flow chart here, I'm actually starting out with 5.4 grams of aluminum. They're asking me to solve for grams of aluminum chloride. So I started out with 5.4 grams of aluminum. They want to know how many grams of aluminum chloride I can make. So I'm trying to get to this of aluminum. So this is my end point over here. Now I can't just jump from here all the way over to here. I've got to follow the flow of the chart. Go to moles of aluminum first. After I'm in moles of aluminum, I'm going to go to my moles of my AlCl3, sorry. And then I can change to my grams of AlCl3. Let's take a look at this and try this problem out. So let's take what we were given, 5.40 grams of aluminum. Let's put that over 1. I started out with 5.4 grams of aluminum. Let's take that value and let's put it over 1. So there we go. That's what I was given. That's what I want to start with. I'm going to multiply by a conversion factor. I'm going to have whatever I had on top in this step here, grams of aluminum. That's going to go on the bottom in the next step. So I'm going to take my grams of aluminum, put it down on the bottom. Oops. Now remember, if I look at this flow chart, what I'm trying to do is I'm trying to go from grams of aluminum now to moles of aluminum. So I'm trying to take my grams and go to moles, and that's what I want to put up on top, since that's what I want to convert to. So I'm going to go to moles of aluminum up on top. And now I've got to do this calculation. How do I go from grams to moles? Well, if we go back to this chart and remember, this is my conversion here. It says that I am going to use the molar mass from the periodic table. We've got to check out the periodic table. I have aluminum to start out with. Here's aluminum on our periodic table. Its mass is 26.98. That means that for this problem right here, what I'm going to do is that 1 mole of Al is equal to 27 grams of Al. That's what I want to use. So I'm actually going to get this number here, the 27 grams. That's going to go next to the 27 down on the bottom, or the grams down on the bottom. That's going to be equal to 1 mole of aluminum. That's how you do that conversion. We did that before in the grams to moles, moles to grams problem that we've looked at. Nothing new there. Don't freak out. You know how to take grams and change them to moles. You know how to take moles and change them to grams. And that's exactly what we just did, using the mass from the periodic table. Let's continue, because I have grams on top and grams on the bottom. That cancels out, but I'm not in the units that I want, so I must continue on. Multiply by another conversion factor. Taking my moles of aluminum now, that's what I have on top in the previous step. Let's take that moles of aluminum, put it down on the bottom. And I want to convert to moles of chlorine. So right now I'm at this part on my flow chart. I've gone from mass to moles. Now I'm in moles of aluminum here, and I actually want to go to moles of my aluminum chloride, I should say. So I'm doing this mole to mole conversion. I'm doing the mole to mole conversion. How do we do that? This is the last video that we just watched, guys. We're going to use the mole ratio, and it says we're going to get that from the balanced equation. So I'm going to use the mole ratio from my balanced equation. I'm trying to take moles of my aluminum, and I'm trying to get my moles of my aluminum chloride. That's what I want to solve for, aluminum chloride. So I'm going to put aluminum chloride up on top because that is what I want to solve for. Moles of aluminum going to moles of aluminum chloride. Well, where do I get this? This is the part that we learned in the last video. This mole to mole ratio, it comes from the equation, right? So how do we do this? Let's look at our balanced equation. Well, for the moles of aluminum, I say that I have 2 moles of aluminum. That's the number I see in my equation. And up on top, when I look at moles of aluminum chloride, I notice that it has a 2 next to it, and that's the number I'm going to put next to the aluminum chloride. That's how you take your moles of aluminum and change it into your moles of aluminum chloride from the mole to mole ratio, the balanced equation. Let's take our final step. I've got the moles on the bottom here, moles of aluminum up on the top here. That cancels out. I'm in moles of aluminum chloride, but I have to solve for grams of aluminum chloride. So I have to multiply by one more step. So we're just going to take this down to the next level here. Multiply by one more step. Whatever I have up on top here, which was the moles of aluminum chloride, I'm going to put that down on the bottom in my next step. Moles of aluminum chloride down on the bottom in this step because I had it up here. Again, just a reminder, we're taking this step here and we're finishing it up just down here. Right? Now I've got moles of aluminum chloride down on the bottom. I'm trying to go out to change these moles into grams. So I want to have my grams of aluminum chloride up on the top. What am I talking about? Well, let's take a look and remember this flow chart. I started out here in the mass. I changed my mass of aluminum to moles of aluminum. The last step, I changed my moles of aluminum to moles of aluminum chloride. My final step, I'm going to change my moles of aluminum chloride to grams of aluminum chloride. And again, anytime I do a mole to gram conversion, it says right here, I got to look at the molar mass from the periodic table. So I have both aluminum and I have chlorine. So I have aluminum chloride, AlCl3. I've got to look this up. Let's take a look at the mass for each of these. Well, aluminum we looked up last time. Aluminum is 26.98. We said we just round that to 27. When I look at chlorine from the periodic table to figure out its atomic mass, it says 35.45. And remember, we said we just wanted to round that to 35. So we just did this. I'm just going to write this up on the top. We just looked this up and we said aluminum has a mass of 27 and chlorine has a mass of 35.5. Well, that's the mass of one aluminum and one chlorine. If we look at aluminum chloride, I've got 3 chlorines here, so I need to multiply this 35.5 by 3. I need to multiply that 35.5 by 3 and then add up my difference. So 35.5, multiply that by 3, I get 106. Run out of room here. And that's 0.5. When I add that to the 27, what I'm going to get is that 1 mole of aluminum chloride is equal to 133.5 grams. These numbers came from the periodic table, right? So 133.5 grams. It says 133.5 grams, so I've got to put 133.5 next to the grams of my aluminum chloride. And that's equal to 1 mole of aluminum chloride. I've got moles of aluminum chloride up on the top and the bottom, and now I'm left in the grams of aluminum chloride that I want. Now let's do the math real quick. Let's multiply everything on the top that we have, which is 5.4, 1, 2, and 133.5. I'm multiplying those 3 numbers together up on top. When I do that, I get 1441.8. Down on the bottom, I have 1, I have 27, I have 2, and I have 1. Multiply those 4 numbers together for my bottom part. When I do that, I get 54. And now I will divide the top and the bottom here to get my answer. And when I do that, I get 26.7, and that's grams of aluminum chloride. That's our first example problem. Hopefully you guys were able to stick with us, figure that out. I know we're kind of running out of space on this. Let's take a look at one more example here, and hopefully you guys can catch on to these mass-to-mass conversion problems. Let's do another one. So here we go, sample problem number 2. It says using the same balanced equation, so boom, we already know the equation. There it is, we did it last time. It says how many grams of chlorine, so what I'm looking for, I write it down, I'm going to do this one in blue. I'm looking for my X grams of chlorine here are needed, and I want to make 30.6 grams of aluminum chloride. So I want to make 30.6 grams of aluminum chloride. That's what I'm starting with. What we're trying to figure out is, well, what do I need to have here to make that amount, right? So I'm looking at how many grams of chlorine do I need to make 30.6 grams of aluminum chloride, right? Let's take what we're given, let's put over 1. Well, I was given 30.6 grams of aluminum chloride. Let's take that value, let's put it over 1. Just like we do every time, take the number and the unit that you're given, put it over 1, multiply by a conversion factor, and let's figure out where we're going. Let's clean this up and look at this one more time with this flow chart here. In the example that we just talked about, we started out with 30.6 grams of aluminum chloride. So I was given 30.6 grams of aluminum chloride. They want me to figure out how many grams of chlorine will I need to do this reaction. So this is where I'm starting. This is where I'm ending over here. I'm starting in mass. I want to end in mass on this side for chlorine. So I'm going to take my grams of aluminum chloride first and change it to moles of aluminum chloride. And in order to do that, we've looked at this multiple times. In order to take grams to moles, it says use the periodic table. Now, if you recall, we just looked at the mass for aluminum chloride in the previous step here. We did it up here. We said aluminum has a mass of 27 and chlorine has a mass of 35.5, and aluminum chloride, I have to multiply that by 3 to get my mass, and we found that it was 133.5. We found that in the last step. So we're just going to use that. We'll save you a little time. But aluminum chloride, I guess I can write it out one more time here. Aluminum has a mass of 27 from the periodic table. Chlorine has a mass of 35.5. Since this was Cl3, I need to multiply this by 3, and this whole thing added up to 133.5 grams. And that was equal to 1 mole. So let's do this conversion. Let's start this problem out. I'm taking my grams of aluminum chloride, and I'm changing it to moles of aluminum chloride. So my grams of aluminum chloride have to go down to the bottom because I have them on the top in the previous step. So they're going to go down on my bottom. My moles of aluminum chloride, that's what I want to go to. Moles of aluminum chloride are going to go up on top. And as we just pointed out earlier, there's my conversion factor, 135.5. There's 133.5 grams for every 1 mole of aluminum chloride. My grams of aluminum chloride will cancel out, and now I'm in moles of aluminum chloride. So let's take a look. I got to do another step here because I got to get all the way to grams of chlorine. On my flow chart, I've now gone from my mass down to moles. Now I'm in moles of AlCl3. I got to get to moles of Cl2. So I'm converting moles of this to moles of this. And in order to do that, it says that you must use the balanced equation. So let's do this conversion. I'm currently in moles of aluminum chloride. I want to go to moles of chlorine. Let's multiply by a conversion factor. Whatever I have on top in the previous steps got to go down on the bottom in the next step. So my moles of aluminum chloride were on the top. They've got to go down on the bottom in the next step. Let me just put this here again so that it doesn't erase. There we go. And I'm trying to convert to moles of Cl2, so that's what I want to have up on top. Moles of Cl2 up on the top. Now, this is the step that we learned in the previous video here, right? We talked about how to go from moles of one substance to moles of another. Again, we said that we're going to get it from the equation. So let's take a look at where these numbers are coming from. In my equation, next to the moles of Cl2, I have the number 3. That's what I'm going to plug into here. There's 3 moles of Cl2 in my equation. Remember, this is like a recipe. It's telling me what I'm going to have. And this recipe says for every 3 moles of chlorine, I'm going to make 2 moles of aluminum chloride. That's the recipe. That's what we have to follow. So this number here and here, they're coming from the balanced equation to convert this. Now, looking at this setup here, I've successfully converted my moles of aluminum chloride to moles of chlorine. But I had to take one more step because they're asking me to get down to grams of chlorine. So I got to extend my page here and take one more step. Let's set up our line here. I have moles of chlorine up on the top, and I'm trying to go down to grams of chlorine. So moles of chlorine up on the bottom in my next step, and I'm trying to go to grams of chlorine. So that's going to go up on the top. Again, here we are on this flow chart. Currently, I'm in moles of chlorine. I'm right here. I got to go to grams of chlorine, and we know we've got to use the periodic table. So let's take a look at it. Remind ourselves the mass of chlorine. Chlorine has a mass of 35.45, which is really just 35, right? So 1 mole of chlorine, kind of write this over here, chlorine has a mass of 35.5, but if I have Cl2, I'm multiplying that by 2 to figure out that 1 mole of chlorine has a mass of 71 grams. So we just said there's 71 grams in 1 mole of chlorine. You know how to do that conversion. You watched it when you guys did the moles to grams, grams to mole problems. You know how to do it. Don't freak out. You just got to bring back that memory. There we go. To get this done. Now we've got everything set back up, and I'm in the grams of chlorine. That's where I want to be at the end. Let's do our math and finish this up. I got 30.6 up on top, I got 1 up on top, I got 3 up on top, and I got 71. When I multiply all those together, up on top I have 6517.8. Down on the bottom, I've got 1, I've got 133.5, I've got 2, and I've got 1. And when I multiply that together, down the bottom I'm going to have 267. Go ahead, do the math. When you do it, you will see you get 24.41, and that's grams of chlorine because we changed our grams of aluminum chloride to the grams of chlorine that we're looking to have. These are grams to grams or mass to mass problems. They are 4-step problems. Hey, I just want to remind you one more time, right? Don't freak out on this stuff. You have done all these things individually. You have done this part of the conversion chart. Mass to moles, moles to mass. You have done moles to moles in the last video. All we're doing now is starting out with something that we're given and changing it to something else, right? So we're doing 4 steps now. We're taking one substance and we're changing it to the mass of something else. You can do it. Talk to me if you have any problems. We'll get some practice with some homework in class, and we'll get you through it. Have a good one.